Question 1. Benchmark analysis indicates that a public pool facility has a primary entry point that is inaccessible to individuals using wheelchairs due to a set of stairs. The Certified Public Pool and Spa Operator, CPO, is tasked with ensuring the facility meets all safety and accessibility requirements for all users. Which of the following actions best addresses this situation in accordance with U.S. regulatory frameworks for public accommodations? Option A. Focus on improving general safety features for the majority of users and defer any accessibility upgrades until a future budget cycle, citing cost as a primary concern. Option B. Install a compliant ramp or lift system that provides safe and accessible entry and exit for individuals with mobility impairments, ensuring it meets all relevant ADA and local building code specifications. Option C. Advise patrons with mobility impairments to seek assistance from other patrons to navigate the stairs, relying on informal help for access. Option D. Post a sign indicating that the main entrance is inaccessible and direct individuals with mobility impairments to a secondary, less convenient entrance that may also have accessibility issues. The correct answer is B. Install a compliant ramp or lift system that provides safe and accessible entry and exit for individuals with mobility impairments, ensuring it meets all relevant ADA and local building code specifications. Explanation: this scenario is professionally challenging because it requires balancing the immediate need for access with the paramount responsibility of ensuring the safety of all pool and spa users, especially those with disabilities. The CPO's role extends beyond routine maintenance to proactive risk management, necessitating a thorough understanding of accessibility regulations and their practical application in a public facility. Careful judgment is required to implement solutions that are both compliant and effective. The correct approach represents best professional practice because it directly addresses the regulatory mandate for accessible entry and exit, as demonstrated by the Americans with Disabilities Act (ADA) in the U.S. context, providing a functional and safe means of entry and exit for individuals with mobility impairments is not merely a suggestion, but a legal requirement. This approach prioritizes inclusivity and safety, ensuring that all patrons can enjoy the facility without undue risk or discrimination. It aligns with the ethical obligation of a CPO to maintain a safe and accessible environment for everyone. An incorrect approach that focuses solely on the convenience of the majority of users, without considering the needs of individuals with disabilities, fails to meet the legal and ethical standards. This would be a direct violation of accessibility laws, such as the ADA, which mandates equal access. Such an approach creates a discriminatory environment and exposes the facility to significant legal liability. Another incorrect approach that involves improvising a solution without proper assessment or adherence to safety standards is also professionally unacceptable. This could lead to unsafe conditions, potential injury, and noncompliance with building codes and accessibility guidelines. It demonstrates a lack of due diligence and a failure to consult appropriate resources or professionals for a safe and compliant solution. A third incorrect approach that prioritizes cost savings over safety and compliance is a critical ethical and regulatory failure. While budget considerations are important, they can never supersede the legal obligation to provide a safe and accessible environment. This approach risks the well-being of patrons and the facility's legal standing. The professional reasoning process for similar situations should involve a systematic approach. 1. Identify the specific regulatory requirements applicable to the facility, including accessibility standards. 2. Assess the current situation and identify any deficiencies or potential hazards related to user safety and accessibility. 3. Research and evaluate potential solutions that are compliant with all relevant regulations and prioritize safety. 4. Consult with relevant authorities or experts if there is any uncertainty regarding compliance or safety. 5. Implement the chosen solution with proper training and ongoing monitoring to ensure its effectiveness and continued compliance. 6. Document all assessments, decisions, and actions taken. Question 2. Strategic planning requires a proactive approach to maintaining optimal free chlorine levels in a busy public swimming pool. Given the need to ensure effective disinfection while minimizing patron discomfort and protecting pool infrastructure, which method of introducing granular chlorine is most aligned with best practices and regulatory compliance for a certified public pool and spa operator? Option A. Pre-dissolving granular chlorine in a separate container of water before adding it to the pool. Option B. Adding granular chlorine directly to the pool surface, allowing it to dissolve naturally. Option C. Relying exclusively on an automated chemical feeder without manual verification. Option D. Adding liquid chlorine directly to the pool without first verifying circulation. The correct answer is A. Pre-dissolving granular chlorine in a separate container of water before adding it to the pool. Explanation. Scenario analysis. This scenario presents a common operational challenge for pool operators: maintaining adequate free chlorine levels in a high-use public pool while managing potential impacts on patron comfort and equipment. The challenge lies in balancing the immediate need for disinfection with the long-term effects of chemical usage, and the need to comply with regulatory standards for water quality. Professional judgment is required to select the most effective and compliant method for achieving and maintaining the target chlorine residual. Correct approach analysis. The correct approach involves a proactive strategy of pre-dissolving granular chlorine in a separate container of water before adding it to the pool. This method ensures that the chlorine is evenly dispersed and begins its disinfection process immediately upon introduction to the pool water, minimizing localized high concentrations that could cause irritation. This aligns with best practices for efficient chemical application and is consistent with the principles of maintaining a safe and healthy aquatic environment as outlined in CPO guidelines, which emphasize proper chemical handling and application to achieve effective sanitation without adverse effects. Incorrect approaches analysis. Adding granular chlorine directly to the pool surface without pre-dissolving is a regulatory and ethical failure. This practice can lead to uneven distribution, creating areas of both overchlorination, causing eye and skin irritation, and potential damage to pool surfaces, and underchlorination, compromising disinfection efficacy. It also poses a risk of damaging the pool's circulation system if the granules settle in skimmers or drains. This directly contravenes CPO recommendations for safe and effective chemical application. Adding liquid chlorine directly to the pool without considering the circulation system's current state is also problematic. A liquid chlorine is generally easier to disperse than granular. Adding it without ensuring adequate water flow can still result in localized high concentrations, leading to patron discomfort and potential equipment damage. It also bypasses a step that could further ensure even distribution, which is a key aspect of responsible pool operation. Relying solely on automated chemical feeders without regular manual testing and adjustment is an ethical and operational failure. Automated feeders are tools, not replacements for operator vigilance. They can malfunction, become clogged, or be miscalibrated, leading to incorrect chlorine levels. CPO certification emphasizes the operator's responsibility for continuous monitoring and testing to ensure water quality, making reliance solely on automation a dereliction of duty. Professional reasoning. Pool operators must adopt a systematic and informed approach to chemical management. This involves understanding the properties of different sanitizers, the dynamics of pool water chemistry, and the specific requirements of the facility. When faced with an implementation challenge, the professional decision-making process should involve 1. Identifying the objective maintaining adequate free chlorine. 2. Evaluating available methods based on efficacy, safety, and regulatory compliance. 3. Considering potential impacts on patrons and equipment. 4. Selecting the method that best achieves the objective while minimizing risks and adhering to established guidelines. Continuous monitoring and testing are paramount to confirm the effectiveness of the chosen method and make necessary adjustments. Question 3. Operational review demonstrates that a public pool facility in a region experiencing consistent sub-freezing temperatures for extended periods requires winterization. The facility has a complex network of plumbing, a heater, a pump, and a filter system. Considering CPO certification standards and regulatory frameworks for public aquatic facilities, which winterization procedure best ensures the protection of equipment in compliance with operational guidelines? Option A. Drain the pool and spa, then fill all plumbing lines and equipment with a non-toxic biodegradable antifreeze solution specifically designed for swimming pool systems. Option B. Drain the pool and spa to a level below the skimmer, and then cover the pool and spa with a winter cover, assuming this will protect the submerged equipment. Option C. Drain the pool and spa to a level below the skimmer and return lines, leaving all equipment connected and filled with water to act as a buffer against freezing. Option D. Completely drain all water from the pool and spa. Blow out all plumbing lines with compressed air to remove residual water, and properly store or protect sensitive equipment like pumps and heaters according to manufacturer recommendations. The correct answer is D. Completely drain all water from the pool and spa. Blow out all plumbing lines with compressed air to remove residual water, and properly store or protect sensitive equipment like pumps and heaters according to manufacturer recommendations. Explanation. This scenario presents a common challenge during the winterization of public pools and spas, balancing the need for thorough protection against freezing with the practical constraints of time, resources, and potential environmental impact. The professional challenge lies in selecting a winterization method that is not only effective, but also compliant with CPO standards and local health codes, while minimizing risks to equipment and the environment. Careful judgment is required to assess the specific conditions of the facility and the chosen method's long-term implications. The correct approach represents best professional practice because it prioritizes the integrity of the pool and spa equipment, ensuring its longevity and preventing costly repairs due to freeze damage. It also adheres to CPO guidelines which emphasize proper draining and protection of all water-bearing components, including plumbing, filters, heaters, and pumps. This method minimizes the risk of water intrusion and subsequent expansion during freezing temperatures, which is a primary concern for preventing damage. Furthermore, it considers the proper disposal of any residual chemicals, aligning with environmental stewardship and regulatory compliance. An incorrect approach that involves simply draining the water and leaving all equipment in place without further protection fails to address the critical risk of residual water freezing within pipes and components. This can lead to cracked pipes, damaged pump seals, and compromised filter housings, resulting in significant repair costs and potential safety hazards. It also violates the principle of comprehensive winterization as taught in CPO certification, which mandates protecting all vulnerable parts. Another incorrect approach, such as using antifreeze solutions not specifically approved for potable water systems or pools/spas, poses a significant environmental and health risk. These solutions can contaminate the water when the pool is reopened, requiring extensive flushing and potentially posing a danger to swimmers. CPO guidelines and health regulations strictly prohibit the use of non-approved chemicals in pool systems. A third incorrect approach, which involves leaving some water in the system to act as a buffer, is a dangerous gamble. While it might seem like a way to avoid complete draining, it does not guarantee protection. The remaining water can still freeze and expand, causing damage, and it can also become stagnant, promoting algae growth and bacterial contamination, which complicates the spring opening process and poses health risks. Professionals should employ a decision-making framework that begins with a thorough assessment of the facility's specific winterization needs, considering climate, equipment type, and local regulations. This involves consulting the CPO manual and any applicable local health department guidelines. The chosen method should be documented, and all steps should be executed meticulously. If in doubt, seeking advice from experienced professionals or equipment manufacturers is a prudent step. The ultimate goal is to protect public health and safety by maintaining a safe and functional facility, while also ensuring the economic viability of the operation through proper equipment maintenance. Question 4. The monitoring system demonstrates a free chlorine reading of 0.5 ppm, a pH of 7.2, and an alkalinity of 100 ppm. Which immediate corrective action best aligns with CPO best practices for ensuring bather safety and regulatory compliance? Option A. Increase total alkalinity to the upper end of the recommended range. Option B. Increase free chlorine levels to the recommended range. Option C. Add an algaecide to prevent potential algae growth. Option D. Adjust pH to the ideal range of 7.4-7.6. The correct answer is B. Increase free chlorine levels to the recommended range. Explanation. This scenario presents a common challenge for certified public pool and spa operators, CPO, where multiple test results indicate potential issues, requiring a nuanced interpretation beyond simple pass/fail thresholds. The professional challenge lies in prioritizing corrective actions based on the severity and interconnectedness of the readings, ensuring both immediate safety and long-term water quality, all while adhering strictly to CPO guidelines and relevant public health regulations for pool operation. The correct approach represents best professional practice because it prioritizes the most critical parameter affecting disinfection efficacy and bather safety. Free chlorine is the primary sanitizer. Its low level directly compromises the pool's ability to kill pathogens, posing an immediate health risk. Addressing this low chlorine level first ensures that the water is adequately disinfected before focusing on other parameters that, while important, do not present the same acute risk. This aligns with the CPO's responsibility to maintain a safe and healthy aquatic environment as mandated by public health codes and CPO training, which emphasizes proactive risk management. An incorrect approach that focuses solely on pH adjustment without first correcting the low chlorine is professionally unacceptable. This fails to address the immediate disinfection deficit, leaving bathers exposed to potential waterborne illnesses. Ethically and regulatorily, this is a failure to uphold the primary duty of ensuring bather safety. Another incorrect approach that might involve adding a large dose of a broad-spectrum algaecide without confirming the chlorine level is also problematic. While algae can be an aesthetic issue, it is secondary to disinfection. Furthermore, without understanding the chlorine status, adding other chemicals could lead to unpredictable reactions or mask the underlying problem, potentially creating new chemical imbalances and failing to address the root cause of the low sanitizer. This demonstrates a lack of systematic problem solving and a disregard for the fundamental principles of pool chemistry and safety. A professional reasoning process for such situations involves a systematic evaluation of all test results, understanding the interdependencies between chemical parameters, and prioritizing actions based on immediate risk to bather health and regulatory compliance. The CPO should first identify the most critical parameter impacting disinfection, then implement corrective measures for that parameter, followed by adjustments to secondary parameters to optimize water balance and overall quality. This methodical approach ensures that all aspects of pool operation are addressed effectively and safely. Question 5. The performance metrics show cyanuric acid levels consistently at the higher end of the acceptable range, with free chlorine readings that, while within the target range, are at the lower end of what is considered optimally effective for disinfection when CYA is elevated. What is the most appropriate immediate operational response? Option A. Immediately begin a process to lower the cyanuric acid concentration to a mid-range level. Option B. Focus solely on maintaining the cyanuric acid within its acceptable range and disregard the free chlorine reading's effectiveness. Option C. Increase free chlorine levels to ensure adequate disinfection despite the higher cyanuric acid concentration. Option D. Maintain current free chlorine levels as they are within the acceptable range and monitor cyanuric acid. The correct answer is C. Increase free chlorine levels to ensure adequate disinfection despite the higher cyanuric acid concentration. Explanation: this scenario is professionally challenging because it requires a pool operator to interpret subtle but significant deviations in water chemistry and understand their direct impact on public health and regulatory compliance, specifically concerning cyanuric acid, CYA. The operator must move beyond simply reading numbers to understanding the underlying chemical interactions and their consequences for swimmer safety and water clarity. The correct approach represents best professional practice because it directly addresses the observed CYA levels in the context of their impact on free chlorine efficacy, a critical factor for disinfection as mandated by public health regulations. Maintaining free chlorine at effective levels, even when CYA is elevated, is paramount for preventing the proliferation of harmful microorganisms. This proactive adjustment demonstrates a thorough understanding of water chemistry and a commitment to public safety, aligning with the core responsibilities of a CPO. An incorrect approach that focuses solely on maintaining a specific CYA range without considering its interaction with free chlorine fails to address the immediate risk to swimmers. Elevated CYA can significantly reduce the sanitizing power of free chlorine, potentially leading to inadequate disinfection and an increased risk of waterborne illnesses. This oversight constitutes a regulatory failure by not ensuring the pool's water is properly sanitized. Another incorrect approach that suggests immediately lowering CYA without assessing the current free chlorine levels could lead to a temporary oversanitization or an unnecessary chemical adjustment, which is inefficient and potentially costly. But more importantly, it misses the opportunity to address the primary concern: the reduced efficacy of the existing sanitizer. A third incorrect approach that ignores the CYA reading altogether is a direct abdication of responsibility, failing to monitor a key water quality parameter and potentially allowing disinfection to be compromised, which is a severe regulatory and ethical breach. Professional reasoning in such situations involves a systematic evaluation. First, identify the deviation: elevated CYA. Second, understand the chemical implications: reduced free chlorine efficacy. Third, assess the immediate risk: inadequate disinfection. Fourth, determine the appropriate corrective action based on current conditions. Adjust free chlorine to compensate for CYA's effect, and plan for eventual CYA reduction if necessary. This process prioritizes swimmer safety and regulatory compliance above all else. Question 6. Benchmark analysis indicates that a public swimming pool facility is experiencing higher than anticipated energy costs for its water circulation system, despite meeting all regulatory requirements for water turnover and disinfection. The facility utilizes a standard centrifugal pump. Considering the potential for operational optimization and energy savings, which of the following pump types would be most professionally recommended for further investigation and potential upgrade? Option A: a positive displacement pump known for its consistent flow regardless of pressure changes. Option B: a standard centrifugal pump with a higher horsepower rating, assuming increased power will improve efficiency. Option C: a submersible pump chosen for its compact design and ease of installation. Option D: a variable speed pump, which allows for precise adjustment of flow rates based on actual demand and operational needs. The correct answer is D: a variable speed pump, which allows for precise adjustment of flow rates based on actual demand and operational needs. Explanation: this scenario presents a common challenge for pool operators: optimizing equipment performance and energy efficiency while ensuring water quality and safety, all within the constraints of regulatory compliance. The professional challenge lies in balancing initial cost versus long-term operational benefits and understanding how different pump technologies impact the overall pool system's effectiveness and adherence to public health standards. Careful judgment is required to select the most appropriate pump type based on the specific needs of the facility, its usage patterns, and the applicable regulations. The correct approach: selecting a variable speed pump when benchmark analysis suggests potential for significant energy savings and improved water turnover, represents best professional practice. This is because variable speed pumps offer precise control over flow rates, allowing operators to match pump speed to the actual demand, thereby reducing energy consumption. This aligns with the CPO's responsibility to operate the facility efficiently and sustainably, which indirectly supports public health by ensuring consistent water treatment. Furthermore, by allowing for lower, consistent flow rates during periods of low bather load, variable speed pumps can enhance filtration effectiveness and chemical distribution, contributing to maintaining water within regulatory parameters for clarity and disinfection. This proactive approach to operational efficiency and water quality management is a hallmark of a competent CPO. An incorrect approach would be to dismiss the potential benefits of a variable speed pump solely based on a higher initial purchase price. This fails to consider the total cost of ownership, including energy savings over the pump's lifespan, which can often offset the initial investment. Ethically, this approach prioritizes short-term cost savings over long-term operational excellence and environmental responsibility, potentially leading to higher ongoing utility expenses and a less efficient system. Another incorrect approach would be to assume that a standard centrifugal pump is always sufficient, regardless of usage patterns or energy efficiency goals. While centrifugal pumps are reliable, they typically operate at a fixed speed, leading to energy waste when full power is not required. This can result in overcirculation, unnecessary wear on equipment, and higher energy bills, failing to meet the professional standard of optimizing operational efficiency. Regulatory implications might arise if the energy inefficiency leads to increased operational costs that are passed on unnecessarily, or if the system's performance is compromised due to inefficient operation. A third incorrect approach would be to prioritize a pump solely based on its maximum flow rate, without considering the actual turnover requirements or the benefits of variable speed. This overlooks the fact that most public pools do not require maximum flow 24/7. Operating a pump at unnecessarily high speeds wastes energy and can lead to excessive wear and tear, compromising the long-term reliability of the equipment and potentially impacting water chemistry due to overagitation. The professional reasoning process for similar situations should involve a comprehensive evaluation of operational needs, energy consumption data, regulatory requirements for water turnover and quality, and the total cost of ownership for different pump technologies. This includes consulting equipment specifications, considering the facility's usage profile, and understanding the long-term implications of equipment choices on both operational costs and environmental impact. A CPO should always strive for solutions that enhance safety, water quality, and operational efficiency in a cost-effective and sustainable manner. Question 7. Governance review demonstrates that a public pool facility is considering implementing a new remote monitoring and control system for its water chemistry and filtration. Which of the following approaches best ensures compliance with Certified Public Pool and Spa Operator (CPO) regulatory requirements? Option A. Adopting the system based on the manufacturer's assurance that it meets general industry standards for pool automation, without independently cross-referencing specific CPO mandates. Option B. Prioritizing the system with the lowest upfront cost and ongoing maintenance fees, assuming that basic automation will inherently satisfy safety requirements. Option C. Deploying the system solely for data logging purposes, with no integrated alarm functions or remote control capabilities, as this minimizes potential system failures. Option D. Implementing the system after verifying that its features and data outputs directly align with all applicable CPO regulations for water quality parameters, alarm thresholds, and emergency response protocols, and establishing clear procedures for human oversight and intervention. Correct answer is D. Implementing the system after verifying that its features and data outputs directly align with all applicable CPO regulations for water quality parameters, alarm thresholds, and emergency response protocols, and establishing clear procedures for human oversight and intervention. Explanation. This scenario presents a professional challenge because the implementation of remote monitoring and control systems for public pools and spas, while offering efficiency, introduces new layers of responsibility and potential vulnerabilities. Ensuring compliance with CPO regulations requires a thorough understanding of how these technologies interact with established safety protocols and legal obligations. The core challenge lies in balancing technological advancement with the paramount duty of public safety and regulatory adherence. The correct approach represents best professional practice because it prioritizes a comprehensive understanding and integration of regulatory requirements into the remote system's design and operation. This involves not just the technical functionality of the remote system, but also its capacity to uphold all CPO-mandated safety standards, including water quality monitoring, emergency response capabilities, and data security. Adherence to these principles ensures that the remote system actively contributes to, rather than compromises, the safe operation of the facility, aligning with the CPO's role as a guardian of public health and safety. An incorrect approach that relies solely on the remote system's manufacturer specifications without independent verification of CPO regulatory compliance is a significant regulatory and ethical failure. This demonstrates a lack of due diligence and an abdication of the CPO's ultimate responsibility for the facility's safety. It assumes the manufacturer's system inherently meets all specific local and national public pool regulations, which is often not the case, leading to potential violations of water chemistry standards, emergency preparedness, or record-keeping requirements. Another incorrect approach that focuses only on cost-effectiveness without considering the system's ability to meet CPO safety mandates is also a failure. Public safety and regulatory compliance are non-negotiable aspects of pool operation. Prioritizing cost over safety and compliance can lead to inadequate monitoring, delayed responses to critical issues, and ultimately, a higher risk of health hazards or accidents, directly contravening the CPO's ethical and legal obligations. Furthermore, an approach that implements remote monitoring without establishing clear protocols for human oversight and intervention is problematic. Remote systems are tools, not replacements for trained personnel. The CPO's role involves active management and decision-making, which includes the ability to override or supplement automated systems. Failing to integrate human oversight creates a critical gap in accountability and emergency response, potentially violating regulations that require qualified personnel to be present or readily available. The professional reasoning process for similar situations should involve a systematic evaluation of any new technology or operational change against the CPO regulatory framework. This includes 1. Identifying all relevant CPO regulations pertaining to the proposed system or change. 2. Assessing the technology's capabilities and limitations in meeting each identified regulatory requirement. 3. Verifying that the system's data collection, reporting, and alarm functions align with CPO standards for water quality, safety, and emergency procedures. 4. Ensuring robust data security and privacy measures are in place, as required by relevant privacy laws that often intersect with public health data. 5. Establishing clear operational procedures that integrate the technology with human oversight and decision-making. 6. Conducting regular audits and reviews to ensure ongoing compliance and effectiveness. Question 8. The control framework reveals a minor, intermittent fluctuation in the pool heater's performance, which management has asked to defer addressing until the next scheduled maintenance cycle to save immediate costs. As a certified public pool and spa operator, CPO, what is the most professionally responsible course of action regarding this heater issue? Option A. Ignore the heater fluctuation, as it is intermittent and has not yet caused a noticeable problem for pool patrons. Option B. Immediately report the issue to management, detailing the potential safety and regulatory implications of a malfunctioning heater and recommending prompt professional assessment and repair, regardless of cost. Option C. Attempt a temporary, self-performed adjustment to the heater to stabilize its performance without involving external technicians or further reporting to management. Option D. Proceed with the deferred maintenance as requested by management, assuming the fluctuation is minor and poses no immediate threat to patron safety or regulatory compliance. The correct answer is B. Immediately report the issue to management, detailing the potential safety and regulatory implications of a malfunctioning heater and recommending prompt professional assessment and repair, regardless of cost. Explanation. Scenario analysis. This scenario presents a common ethical dilemma for a certified public pool and spa operator, CPO, where a perceived cost-saving measure by management conflicts with established safety protocols and potentially regulatory requirements. The challenge lies in balancing the operator's duty to ensure public safety and compliance with the pressure to minimize operational expenses. Ignoring a known issue with a heater, even if it appears minor, can have serious consequences, including potential equipment failure, increased energy consumption, and most importantly, compromising the safety and comfort of pool patrons. The operator must navigate this conflict by prioritizing safety and regulatory adherence over immediate financial considerations. Correct approach analysis. The correct approach involves clearly communicating the potential risks associated with the heater issue to management, referencing specific CPO guidelines and potentially local health department regulations regarding equipment functionality and safety. This approach upholds the CPO's ethical obligation to protect public health and safety, which is paramount. It also demonstrates professional integrity by advocating for necessary maintenance and repairs, ensuring the pool operates within safe parameters and complies with all applicable standards. This proactive communication and adherence to best practices prevent potential future liabilities and ensure a safe aquatic environment. Incorrect approaches analysis. One incorrect approach involves deferring the repair to save money. This is ethically and regulatorily unsound because it prioritizes cost over safety. CPO guidelines and regulations often mandate that all pool equipment, including heaters, must be in good working order to maintain proper water temperature and prevent hazards. Failing to address a known issue, even if seemingly minor, could lead to a violation of health codes, potential patron injury, e.g., from inadequate heating or equipment malfunction, and damage to the operator's professional reputation and certification. Another incorrect approach is to attempt a temporary fix without proper diagnosis or authorization. This bypasses established maintenance protocols and could mask a more significant underlying problem. It is unprofessional and potentially dangerous, as a temporary fix might fail unexpectedly, leading to a safety hazard or more extensive damage. It also undermines the systematic troubleshooting and repair processes expected of a certified operator. A third incorrect approach is to ignore the issue altogether, assuming it will resolve itself or is not significant enough to warrant attention. This is a dereliction of duty for a CPO. The operator's responsibility includes regular inspection and maintenance of all pool systems. Ignoring a known problem is negligent and directly violates the principle of proactive safety management central to CPO certification. It exposes the facility to potential regulatory penalties and places patrons at risk. Professional reasoning. When faced with such a dilemma, a CPO should follow a structured decision-making process. 1. Identify the potential safety and regulatory implications of the issue. 2. Consult relevant CPO guidelines, operational manuals, and local health codes. 3. Clearly and professionally communicate the findings, risks, and recommended course of action to management, providing justification based on safety and regulations. 4. Document all communications and decisions. 5. If management insists on delaying necessary repairs, the CPO should reiterate the risks and potentially escalate the concern through appropriate channels, prioritizing public safety above all else. Question 9. Compliance review shows that a certified public pool and spa operator is consistently obtaining test results for free chlorine that appear unusually low, even after adding standard doses of disinfectant. The operator has not performed any recent checks on the test kit or its reagents. What is the most appropriate immediate course of action to ensure accurate water testing and maintain public safety? Option A. Immediately verify the expiration dates of all test kit reagents and perform a calibration check of the test kit according to manufacturer instructions and regulatory guidelines. Option B. Discontinue using the current test kit and purchase a new one without further investigation into the current kit's performance. Option C. Rely on visual inspection of the water clarity to determine if disinfection levels are adequate, as clear water generally indicates proper treatment. Option D. Continue adding disinfectant based on the low test results, assuming the water chemistry is demanding more chlorine than usual. The correct answer is A. Immediately verify the expiration dates of all test kit reagents and perform a calibration check of the test kit according to manufacturer instructions and regulatory guidelines. Explanation. This scenario presents a common challenge in pool and spa operations, ensuring the accuracy and reliability of water testing, which directly impacts public health and safety. The professional challenge lies in maintaining a consistent and compliant testing program amidst potential issues with equipment and reagents. Careful judgment is required to identify and rectify problems promptly, preventing potential health risks associated with improperly treated water. The correct approach represents best professional practice because it directly addresses the root cause of potential inaccuracies by verifying the expiration dates and proper storage of reagents, and by calibrating the test kit according to manufacturer instructions and regulatory guidelines. The operator ensures the integrity of the testing process. This proactive measure aligns with CPO certification standards, which emphasize accurate water parameter monitoring for safe operation. It demonstrates a commitment to regulatory compliance and the prevention of waterborne illnesses. An incorrect approach that involves using reagents past their expiration date is a significant regulatory and ethical failure. Expiration dates are established to guarantee the chemical stability and accuracy of reagents. Using expired reagents can lead to inaccurate test results, potentially causing the pool operator to misjudge the required chemical dosages. This could result in water that is inadequately disinfected or unbalanced, posing a direct health risk to swimmers and violating public health codes that mandate proper water treatment. Another incorrect approach, such as assuming the test kit is accurate without performing regular calibration checks, is also a failure. Calibration ensures that the test kit is functioning correctly and providing reliable readings. Without calibration, even with in-date reagents, the kit might be delivering false results, leading to improper chemical adjustments and compromised water quality. This disregard for proper equipment maintenance and verification undermines the operator's responsibility to maintain a safe aquatic environment. Finally, an incorrect approach that involves relying solely on visual inspection of water clarity as a substitute for chemical testing is a critical failure. While water clarity is an indicator of water quality, it does not provide information about essential parameters like disinfectant levels, pH, or alkalinity. Relying only on visual cues can lead to a false sense of security, masking underlying chemical imbalances that could promote pathogen growth. This approach neglects the fundamental requirements of water chemistry monitoring, mandated by CPO standards and public health regulations. The professional decision-making process for similar situations should involve a systematic approach to troubleshooting and verification. When test results appear inconsistent or when there is any doubt about their accuracy, the operator should immediately 1. Review the expiration dates of all reagents. 2. Inspect reagents for any signs of degradation, e.g., discoloration, precipitation. 3. Verify the proper storage conditions of reagents. 4. Perform calibration checks on the test kit according to manufacturer guidelines and regulatory requirements. 5. If issues persist, consult the test kit manufacturer or seek guidance from regulatory authorities. This methodical process ensures that water testing is consistently accurate and that the pool or spa remains safe for public use. Question 10. Risk assessment procedures indicate a sudden and significant drop in free chlorine levels in a public swimming pool, accompanied by a noticeable increase in turbidity. The pool operator has a standard test kit and a backup comparator kit available. What is the most appropriate immediate course of action to address this situation? Option A. Add a coagulant to help clarify the water, assuming the chlorine loss is a secondary effect of the turbidity. Option B. Immediately add a large dose of a chlorine-based shock treatment to re-establish free chlorine levels and clarify the water. Option C. Visually inspect the pool for any obvious sources of contamination, such as debris or fecal matter, and remove them before testing. Option D. Use the backup comparator kit to retest the free chlorine and pH levels, then consult the facility's operational plan for specific shock treatment procedures. The correct answer is B. Immediately add a large dose of a chlorine-based shock treatment to re-establish free chlorine levels and clarify the water. Explanation. The scenario presents a common challenge in pool and spa operation, responding to a sudden, significant shift in water chemistry that could compromise patron safety and facility compliance. The professional challenge lies in accurately diagnosing the cause and implementing the correct corrective action swiftly and effectively, adhering strictly to established protocols and regulatory requirements. This requires not just knowledge of chemistry, but also an understanding of how different factors interact and the potential consequences of incorrect interventions. The correct approach prioritizes a systematic, evidence-based response. It involves first confirming the observed readings with a secondary test kit to ensure accuracy, a fundamental step in any diagnostic process. Following this, it necessitates identifying the specific chemical imbalance and then consulting the facility's operational plan and relevant CPO guidelines for the appropriate corrective chemical and dosage. This methodical process ensures that interventions are targeted, safe, and compliant with public health standards, minimizing risks to swimmers and avoiding potential regulatory violations. An incorrect approach might involve making assumptions about the cause without verification. For instance, immediately adding a broad-spectrum sanitizer without confirming the specific deficiency or excess could lead to overtreatment, creating a new set of chemical imbalances and potential health hazards. This bypasses the critical step of accurate diagnosis and could violate CPO guidelines regarding safe chemical handling and application. Another incorrect approach might be to rely solely on visual cues or anecdotal evidence rather than objective water testing. This is a direct contravention of regulatory requirements that mandate regular, accurate water testing to ensure safe operating conditions. Furthermore, failing to consult established operational plans or CPO guidelines before adding chemicals represents a failure to follow mandated procedures, potentially leading to improper dosages or the use of incompatible chemicals, both of which are regulatory and ethical breaches. Professional decision-making in such situations should follow a clear framework. 1. Verify data. Always confirm initial readings with a reliable secondary method. 2. Diagnose. Identify the specific chemical imbalance based on verified data. 3. Consult. Refer to the facility's operational plan, CPO guidelines, and manufacturer instructions for corrective actions. 4. Implement. Apply the correct chemical at the precise dosage recommended. 5. Monitor. Retest water chemistry to confirm the effectiveness of the intervention and ensure stability. This systematic approach ensures safety, compliance, and operational integrity. Question 11. Quality control measures reveal that the chemical feeder for the spa at the community recreation center is intermittently malfunctioning, leading to fluctuations in chlorine levels that occasionally dip below the minimum required concentration as stipulated by the local health department regulations. The spa is currently open and in use by patrons. Option A. Immediately close the spa to patrons and contact the local health department for guidance on how to rectify the situation and when it is safe to reopen. Option B. Temporarily reduce the number of patrons allowed in the spa to mitigate the risk associated with lower chlorine levels. Option C. Continue operating the spa but increase manual chlorine testing frequency to hourly and add chlorine manually as needed until the feeder can be repaired. Option D. Inform the spa patrons verbally about the potential chlorine fluctuation and advise them to exit if they experience any discomfort. The correct answer is A. Immediately close the spa to patrons and contact the local health department for guidance on how to rectify the situation and when it is safe to reopen. Explanation: this scenario is professionally challenging because it requires the pool operator to balance immediate operational needs with strict adherence to local health department regulations, which are designed to protect public health. The operator must make a judgment call based on incomplete information and potential risks. The correct approach represents best professional practice because it prioritizes public safety and regulatory compliance. By immediately contacting the local health department, the operator is proactively addressing a potential violation and seeking official guidance. This demonstrates a commitment to following established protocols and ensuring the facility operates within legal and safety standards. This action aligns with the CPO's responsibility to maintain a safe and healthy aquatic environment as mandated by local health codes. An incorrect approach that involves ignoring the issue or attempting to self-correct without consulting the health department is professionally unacceptable. Ignoring the issue is a direct violation of the operator's duty to report and address potential health hazards, which could lead to severe public health consequences and significant legal penalties for the facility. Attempting to self-correct without official guidance risks misinterpreting the regulation or implementing an ineffective solution, potentially leaving the hazard unaddressed or creating new ones. This failure to consult the governing authority is a breach of professional responsibility and regulatory compliance. Another incorrect approach, such as continuing operations while hoping the issue resolves itself, is equally problematic. This demonstrates a lack of diligence and a disregard for the potential risks to patrons. It suggests a prioritization of convenience or cost-saving over public safety and regulatory adherence, which is a fundamental ethical and professional failing for a CPO. The professional decision-making process in such situations should involve 1. Recognizing a potential deviation from established safety or regulatory standards. 2. Assessing the immediate risk to public health. 3. Consulting relevant regulations and operational manuals. 4. If uncertainty or a potential violation exists, immediately contacting the appropriate regulatory authority for clarification and guidance. 5. Documenting all communications and actions taken. Question 12. The evaluation methodology shows a lifeguard on duty at a busy public pool observing a patron in the water who appears to be struggling to stay afloat and is not moving their arms or legs effectively. The patron is not calling for help, but their head is bobbing just above the water's surface. What is the most appropriate immediate course of action for the lifeguard? Option A. Shout loudly at the patron to ask if they are okay and wait for a verbal response. Option B. Assume the patron is playing or being difficult and continue to monitor other areas of the pool. Option C. Continue to observe the patron for another 30 seconds to confirm if they are in distress before taking any action. Option D. Immediately activate the facility's emergency action plan, enter the water to perform a rescue if necessary, and ensure appropriate medical assistance is summoned. The correct answer is D. Immediately activate the facility's emergency action plan, enter the water to perform a rescue if necessary, and ensure appropriate medical assistance is summoned. Explanation: this scenario is professionally challenging because it requires immediate, decisive action under pressure, where the lifeguard's training and adherence to established protocols are paramount to ensuring patron safety. The lifeguard must quickly assess the situation, differentiate between a minor issue and a life-threatening emergency, and initiate the appropriate response without hesitation. The presence of multiple patrons and potential distractions further complicates the situation, demanding focused attention and clear communication. The correct approach represents best professional practice because it directly aligns with the core principles of lifeguarding and emergency procedures, as mandated by the Certified Public Pool and Spa Operator (CPO) curriculum. This approach prioritizes immediate recognition of a potential distress situation, followed by a swift and systematic activation of the facility's Emergency Action Plan (EAP). This includes alerting other staff, initiating rescue procedures if necessary, and ensuring appropriate medical assistance is summoned. This systematic response minimizes the time to intervention, maximizes the chances of a positive outcome, and fulfills the lifeguard's legal and ethical duty of care. An incorrect approach that involves observing the patron for an extended period before acting fails to meet the standard of care. This delay could be critical in a drowning or near-drowning situation, where seconds matter. Ethically, it represents a failure to act promptly when a patron's safety is in jeopardy. Legally, it could be construed as negligence, as the lifeguard did not take reasonable steps to prevent harm. Another incorrect approach, such as shouting at the patron to see if they are okay without initiating a rescue or activating the EAP, is insufficient. While communication is part of lifeguarding, it is not a substitute for a proper emergency response when distress is suspected. This approach risks misinterpreting the patron's condition and delays the activation of critical emergency services. It demonstrates a lack of understanding of the urgency required in potential aquatic emergencies and a failure to follow established emergency protocols. A third incorrect approach, such as assuming the patron is merely playing or being difficult, is a dangerous assumption that can have fatal consequences. Lifeguards are trained to err on the side of caution and to treat any sign of distress as a potential emergency until proven otherwise. This approach demonstrates a critical lapse in judgment and a disregard for the established safety procedures designed to protect patrons. It prioritizes convenience or avoidance of perceived overreaction over the paramount duty of ensuring patron safety. Professional decision-making in such situations relies on a framework of continuous vigilance, rapid assessment, and decisive action based on training. Lifeguards must constantly scan their assigned zones, be aware of patron behavior, and be prepared to activate the EAP at the first sign of distress. This involves recognizing the subtle cues of a struggling swimmer and understanding that immediate intervention is often necessary. The decision-making process should be ingrained through regular training and drills, ensuring that the correct response becomes instinctive under pressure. Question 13. Cost-benefit analysis shows that a quicker brushing technique can save significant labor time, but CPO regulations mandate thorough removal of debris and biofilm. Which brushing approach best aligns with CPO operational requirements for public pools? Option A. Utilizing a rapid, sweeping brushing motion across large surface areas, focusing primarily on visible debris and assuming chemical treatment will address any remaining biofilm. Option B. Adopting a brushing schedule that prioritizes aesthetic appearance over thoroughness, with less frequent and less intensive brushing of all surfaces. Option C. Concentrating brushing efforts only on the pool floor and high-traffic areas, deeming less visible surfaces as lower priority for physical agitation. Option D. Employing a brushing technique that systematically covers all pool surfaces, including walls, floor, steps, and around fittings, ensuring visible debris is dislodged, and potential biofilm is agitated for subsequent filtration and chemical treatment. The correct answer is D. Employing a brushing technique that systematically covers all pool surfaces, including walls, floor, steps, and around fittings, ensuring visible debris is dislodged and potential biofilm is agitated for subsequent filtration and chemical treatment. Explanation. This scenario is professionally challenging because it requires balancing operational efficiency with the absolute priority of public health and safety as mandated by CPO regulations. The core of the challenge lies in determining the most effective and compliant method for brushing pool surfaces, considering factors beyond mere time or cost. The correct approach represents best professional practice because it directly addresses the regulatory requirement for effective debris removal and pathogen control. CPO guidelines emphasize that brushing is not just about aesthetics, but is a critical step in dislodging biofilm and organic matter that can harbor pathogens, thereby preventing their proliferation and ensuring water quality. This proactive measure is a cornerstone of preventing waterborne illnesses, a primary ethical and regulatory obligation. An incorrect approach that prioritizes speed over thoroughness fails to meet the regulatory standard for effective cleaning. This could lead to the accumulation of biofilm, creating a breeding ground for bacteria and viruses, which directly violates the CPO's mandate to maintain a safe aquatic environment. Ethically, this represents negligence in fulfilling the duty of care to pool patrons. Another incorrect approach that relies solely on chemical treatment without adequate physical cleaning is also a regulatory failure. While chemicals are essential for disinfection, they are less effective against established biofilm. Inadequate brushing allows biofilm to persist, potentially leading to chemical resistance and reduced disinfection efficacy, compromising patron safety and violating the comprehensive approach to pool operation required by CPO standards. Finally, an approach that neglects specific areas like grout lines or underwater fixtures, even if time-efficient, is a failure to adhere to best practices for comprehensive cleaning. These areas are prone to biofilm accumulation and require diligent attention. Failing to address them creates hidden risks, undermining the overall safety of the pool and contravening the spirit and letter of CPO regulations, which demand meticulous attention to detail in maintaining a healthy aquatic environment. Professionals should use a decision-making framework that begins with understanding the explicit regulatory requirements for pool maintenance, particularly those related to cleaning and disinfection. This should be followed by an assessment of the practical implications of different cleaning methods on pathogen control and water quality. The most effective approach will be the one that demonstrably achieves the highest level of compliance with CPO standards for patron safety, even if it requires slightly more time or resources than a superficially quicker method. Question 14. Assessment of a CPO's ethical responsibility when a facility manager requests to delay essential filter maintenance, citing budget constraints, despite the CPO's professional judgment that the delay will compromise water clarity and filtration efficiency, potentially impacting patron safety and regulatory compliance. Option A. Lightly but firmly explain to the facility manager the critical role of the filtration system in maintaining water quality and preventing the spread of pathogens, referencing specific CPO training principles and potential health code violations if maintenance is deferred, and document the recommendation for immediate action. Option B. Agree to the manager's request to postpone the maintenance to avoid conflict and demonstrate cost consciousness, assuming the filter can function adequately for a short period. Option C. Implement a temporary, less effective cleaning method for the filter media without informing the manager, hoping it will suffice until the budget allows for proper maintenance. Option D. Proceed with the filter maintenance immediately without seeking further approval from the facility manager, prioritizing the perceived immediate need over established operational procedures. The correct answer is A. Politely but firmly explain to the facility manager the critical role of the filtration system in maintaining water quality and preventing the spread of pathogens, referencing specific CPO training principles and potential health code violations if maintenance is deferred, and document the recommendation for immediate action. Explanation. This scenario presents a common ethical dilemma for a certified public pool and spa operator, CPO, where a facility manager prioritizes cost savings over essential maintenance, potentially compromising public safety and regulatory compliance. The challenge lies in balancing operational efficiency with the non-negotiable duty to maintain a safe and healthy aquatic environment as mandated by CPO certification and relevant public health regulations. The correct approach involves advocating for the necessary filter maintenance, even if it incurs immediate costs. This aligns with best professional practice because it directly addresses the core responsibilities of a CPO, ensuring water clarity, effective pathogen removal, and adherence to all applicable health codes. Properly functioning filtration systems are critical to preventing the spread of waterborne illnesses, a primary concern for public pools and spas. Regulatory frameworks, such as those enforced by the local health department and outlined in CPO training, emphasize the importance of maintaining equipment to meet water quality standards. An incorrect approach would be to agree to the manager's request to postpone the filter maintenance. This action represents a significant regulatory failure because it directly violates the principle of maintaining equipment to ensure water quality. Ethically, it is a failure to uphold the duty of care owed to the public. Another incorrect approach would be to suggest a temporary, less effective workaround without proper justification or regulatory approval. This could lead to a false sense of security while still posing a risk to patrons and failing to meet the operational standards required by law. Finally, ignoring the manager's request and proceeding with maintenance without authorization would be an ethical and professional failure, as it bypasses established communication and approval channels within the facility's management structure. Professional decision-making in such situations requires a clear understanding of regulatory requirements, a commitment to public safety, and effective communication skills. A CPO should first clearly articulate the risks associated with neglecting filter maintenance, referencing specific health code requirements or CPO training principles. If the manager remains resistant, the CPO should document their concerns and recommendations, and if necessary, escalate the issue to higher management or the relevant regulatory authority, ensuring all actions are transparent and defensible. Question 15. Comparative studies suggest that different forms of bromine, such as sodium bromide activated by an oxidizer or stabilized bromine compounds, offer varying benefits in pool and spa sanitation. A certified public pool and spa operator is tasked with maintaining optimal water chemistry in a busy public facility. Considering the importance of accurate monitoring for effective sanitation and regulatory compliance, which of the following actions best demonstrates adherence to professional standards and best practices for bromine management? Option A. Rely on the visual appearance of the water and the absence of odor as primary indicators of adequate bromine sanitation, assuming the chosen bromine product is functioning effectively. Option B. Regularly test the pool water for both free bromine and total bromine using a reliable test kit, and adjust chemical levels based on these readings to maintain the recommended disinfectant residual. Option C. Conduct a single daily test for total bromine only, and assume that maintaining a consistent level of total bromine ensures sufficient free bromine for sanitation. Option D. Administer a broad-spectrum test for oxidizer levels, assuming this accurately reflects the active sanitizing capacity of any bromine present in the water. The correct answer is B. Regularly test the pool water for both free bromine and total bromine using a reliable test kit, and adjust chemical levels based on these readings to maintain the recommended disinfectant residual. Explanation: this scenario is professionally challenging because it requires the pool operator to balance the effectiveness of different bromine types with regulatory compliance and patron safety. The operator must understand the chemical properties of each bromine form, their appropriate applications, and the testing methods that accurately reflect their presence and efficacy in the water. Misjudging these factors can lead to inadequate sanitation, potential health risks for swimmers, and non-compliance with public health standards. The correct approach represents best professional practice because it prioritizes accurate water testing to confirm the presence and effectiveness of the chosen bromine sanitizer. This aligns with CPO certification principles, which emphasize maintaining water quality through diligent monitoring and appropriate chemical application. Specifically, using a test kit capable of measuring both total and free bromine ensures the operator can assess the active sanitizing form and its potential for reaction with contaminants. This proactive testing allows for informed adjustments to maintain the disinfectant residual within acceptable regulatory limits, thereby ensuring patron safety and compliance. An incorrect approach that relies solely on visual cues or a single, less specific test method fails to provide the necessary data for effective water management. For instance, testing only for total bromine without also measuring free bromine can mask a situation where the bromine is largely combined with contaminants and no longer effectively sanitizing the water. This represents a regulatory failure because it does not demonstrate due diligence in maintaining a safe and sanitary environment as required by public health codes. Ethically, it compromises the operator's responsibility to protect public health. Another incorrect approach might involve assuming a specific bromine type will perform identically to another without verification, leading to potential undersanitation if the chosen product is less potent or reacts differently under the pool's specific conditions. This is a failure in professional judgment and can lead to non-compliance with sanitation standards. Professionals should approach such situations by first understanding the available bromine sanitizers and their recommended applications. They should then select a testing method that can accurately measure the active sanitizer residual and its relationship to combined bromine. Regular testing, interpretation of results in the context of regulatory requirements, and making informed adjustments to chemical dosages are crucial. This systematic process ensures that the pool remains safe, compliant, and enjoyable for all patrons. Question 16. Strategic planning requires a comprehensive approach to maintaining the aesthetic and sanitary condition of public pool tiles and walls. Considering the potential impact on water chemistry and patron safety, which of the following cleaning strategies best aligns with Certified Public Pool and Spa Operator (CPO) guidelines? Option A. Focusing solely on skimming the water surface and brushing the pool floor, neglecting the regular cleaning of tiles and walls. Option B. Scrubbing the tiles and walls vigorously with abrasive pads or steel wool to ensure all visible dirt is removed. Option C. Utilizing common household cleaning agents such as bleach or all-purpose cleaners to remove stubborn stains and grime from the tiles and walls. Option D. Employing specialized pool tile and wall cleaners, ensuring proper dilution and thorough rinsing to prevent chemical residue from entering the pool water. Correct answer is D. Employing specialized pool tile and wall cleaners, ensuring proper dilution and thorough rinsing to prevent chemical residue from entering the pool water. Explanation: this scenario is professionally challenging because maintaining a clean and safe aquatic environment is paramount for public health and patron enjoyment. The specific challenge lies in balancing the need for effective cleaning with the potential for introducing harmful chemicals or damaging the pool surface. Careful judgment is required to select cleaning methods and products that are both efficient and compliant with CPO standards, which prioritize water quality and patron safety. The correct approach represents best professional practice because it directly addresses the need for effective tile and wall cleaning while adhering to CPO guidelines. This involves using appropriate cleaning agents that are specifically designed for pool surfaces, ensuring they are diluted correctly, and thoroughly rinsing the pool to remove any residual chemicals. This method prevents chemical imbalances in the water, protects the integrity of the pool surfaces, and minimizes any risk to swimmers. It aligns with the CPO's emphasis on maintaining water chemistry and preventing contamination. An incorrect approach that involves using household cleaners or abrasive materials poses significant regulatory and ethical failures. Household cleaners may contain chemicals that are not safe for pool water, potentially leading to adverse reactions in swimmers or disrupting the carefully balanced water chemistry. Abrasive materials can damage the pool tiles and grout, leading to costly repairs and creating surfaces that are more prone to harboring bacteria. Ethically, using unapproved or unsafe cleaning methods violates the duty of care owed to pool patrons. Another incorrect approach, such as neglecting regular cleaning of tiles and walls, fails to meet the basic operational standards for a public pool, creating an unsanitary environment and increasing the risk of algae growth and slippery surfaces, which are safety hazards. This directly contravenes the CPO's mandate for maintaining a hygienic and safe aquatic facility. Professionals should employ a decision-making framework that prioritizes safety, regulatory compliance, and efficacy. This involves first identifying the specific cleaning needs of the tiles and walls, then researching and selecting cleaning products approved for pool use and compatible with the pool's materials. Always consult the Product Safety Data Sheet (SDS) and follow manufacturer instructions for dilution and application. Thorough rinsing and ensuring proper water chemistry balance post-cleaning are critical steps. Regular inspection of pool surfaces for wear and tear should also inform cleaning practices. Question 17. To address the challenge of a new shipment of pool chemicals arriving during peak operating hours, and with staff eager to begin treatment to maintain water quality, what is the most responsible and legally compliant course of action regarding the handling and use of these chemicals? Option A. Immediately begin using the chemicals as directed by the supplier's representative, as operational demands are high and the supplier is presumed to be knowledgeable. Option B. Proceed with using the chemicals based on general knowledge of similar pool treatments, deferring a thorough MSDS review until after the busy period has passed. Option C. Halt all chemical treatment until the Material Safety Data Sheet (MSDS) for each new chemical is located, reviewed by the designated safety officer, and all necessary safety precautions are implemented. Option D. Delegate the task of reviewing the MSDS to a junior staff member who can quickly skim it while operations continue, assuming the risks are minimal. The correct answer is A. Immediately begin using the chemicals as directed by the supplier's representative, as operational demands are high and the supplier is presumed to be knowledgeable. Explanation. This scenario presents a professional challenge because it involves a potential safety hazard and a conflict between immediate operational needs and regulatory compliance. The pool operator must balance the urgency of maintaining pool operations with the critical requirement of ensuring staff safety and adherence to proper chemical handling procedures. Careful judgment is required to avoid compromising either aspect. The correct approach represents best professional practice because it prioritizes safety and regulatory compliance. Accessing and understanding the MSDS for the newly delivered chemical is paramount. This document provides essential information on hazards, safe handling, personal protective equipment (PPE), and emergency procedures. By consulting the MSDS before use, the operator ensures that staff are adequately protected and that the chemical is stored and handled according to established safety protocols, thereby preventing potential accidents or exposures. This aligns with the fundamental principles of responsible pool operation and the legal obligations to provide a safe working environment. An incorrect approach that involves using the chemical immediately without consulting the MSDS is a significant regulatory and ethical failure. This action directly violates the principle of informed consent and due diligence regarding chemical safety. It exposes staff to unknown risks, potentially leading to injuries or health issues. Furthermore, it disregards the explicit requirements of regulatory frameworks that mandate access to and understanding of chemical safety information. Another incorrect approach, such as relying solely on the chemical supplier's verbal assurance without verifying the information through the MSDS, is also professionally unacceptable. While the supplier may be knowledgeable, verbal information can be incomplete, misinterpreted, or lack the detailed, documented safety data required by regulations. This approach bypasses the established, legally recognized method for communicating chemical hazards and safety precautions. The professional decision-making process for similar situations should involve a systematic approach. 1. Identify the hazard. Recognize that a new chemical presents potential risks. 2. Consult the documentation. Immediately locate and review the material safety data sheet (MSDS) for the chemical. 3. Assess the risks. Based on the MSDS, determine the specific hazards and necessary precautions. 4. Implement controls. Ensure appropriate PPE is available and used and that handling and storage procedures are followed. 5. Train staff. Educate all personnel who will handle or be exposed to the chemical about its risks and safe handling practices. 6. Document. Maintain records of chemical inventory, MSDS access, and staff training. Question 18. Stakeholder feedback indicates that the water in the public pool has appeared cloudy for the past 2 days, and some patrons have commented on a gritty feeling. The pool is equipped with a DE diatomaceous earth filter. What is the most appropriate immediate course of action for the certified public pool and spa operator? Option A. Perform a full backwash of the DE filter, followed by adding the appropriate amount of new DE powder according to manufacturer specifications and CPO guidelines. Option B. Visually inspect the pool walls and floor for any visible debris and manually skim the surface. Option C. Immediately shock the pool with a high dose of chlorine to address any potential microbial causes of cloudiness. Option D. Consult the pool's chemical test results from the past week to see if any parameters are significantly out of range. Correct answer is A. Perform a full backwash of the DE filter, followed by adding the appropriate amount of new DE powder according to manufacturer specifications and CPO guidelines. Explanation. This scenario presents a common challenge in pool and spa operations, balancing immediate operational needs with long-term equipment health and regulatory compliance. The professional challenge lies in interpreting stakeholder feedback, which can be subjective, and translating it into concrete, effective maintenance actions that adhere to CPO standards. The need for careful judgment arises because filter performance directly impacts water clarity, safety, and patron experience, all of which are governed by CPO guidelines. The correct approach represents best professional practice because it prioritizes a systematic, evidence-based method for diagnosing and addressing filter issues. This involves understanding the specific type of filter, its operational parameters, and the typical indicators of malfunction. By consulting the manufacturer's guidelines and CPO recommendations for filter cleaning and maintenance, The operator ensures that the chosen method is both effective for the specific filter type and compliant with established safety and operational standards. This proactive and informed approach prevents potential water quality issues, extends equipment life, and minimizes the risk of regulatory violations related to water clarity or sanitation. An incorrect approach that relies solely on visual cues without understanding the underlying filter mechanics is professionally unacceptable. For example, simply backwashing a sand filter when the pressure gauge indicates a need, without considering the frequency or effectiveness of previous backwashes, could lead to premature sand degradation or ineffective particulate removal, potentially violating CPO guidelines for water clarity. Similarly, using harsh chemicals to clean a cartridge filter without consulting manufacturer specifications or CPO guidelines could damage the filter media, compromise its filtration efficiency, and lead to the release of harmful substances into the water, a clear ethical and regulatory failure. Another incorrect approach might be to ignore the feedback altogether, assuming it is an overreaction, which demonstrates a failure to address patron concerns and a disregard for potential underlying operational issues that could lead to noncompliance with CPO water quality standards. Professional reasoning in such situations requires a multifaceted approach. First, acknowledge and investigate all stakeholder feedback. Second, consult relevant documentation, including manufacturer manuals for the specific filter equipment and the CPO handbook for operational standards and recommended maintenance procedures. Third, use diagnostic tools like pressure gauges in conjunction with an understanding of filter principles to identify the root cause of any perceived issue. Finally, implement maintenance procedures that are appropriate for the filter type, effective in resolving the issue, and fully compliant with CPO regulations. Question 19. Market research demonstrates that various methods exist for selecting a pool pump. Considering the Certified Public Pool and Spa Operator (CPO) regulatory framework, which approach best ensures compliance with operational standards and promotes efficient, safe water circulation for a new public swimming pool. Option A. Selecting the pump with the lowest initial purchase price, assuming it will meet basic operational needs. Option B. Relying exclusively on the pump manufacturer's general recommendation for a pool of similar size, without specific system calculations. Option C. Choosing a pump based on a detailed hydraulic analysis of the pool system, including total dynamic head and desired turnover rate, to match the pump's performance curve to the system's requirements. Option D. Opting for the largest capacity pump available to guarantee rapid water turnover, regardless of system design or energy efficiency. Correct answer is A. Selecting the pump with the lowest initial purchase price, assuming it will meet basic operational needs. Explanation. This scenario presents a common challenge in pool and spa operations, selecting the appropriate pump for a new facility. The challenge lies in balancing initial cost with long-term operational efficiency, water quality, and regulatory compliance. A pump that is undersized will struggle to meet turnover requirements, leading to poor water circulation and potential health code violations. Conversely, an oversized pump can lead to excessive energy consumption, unnecessary wear and tear, and potentially turbulent water flow that can negatively impact chemical distribution and bather comfort. Professional judgment is required to identify the pump that best meets the specific needs of the facility while adhering to all applicable regulations. The correct approach involves a comprehensive evaluation of the pool or spa's hydraulic requirements, considering factors such as the total dynamic head, TDH, desired flow rate for adequate water turnover as mandated by CPO guidelines and local health codes, and the specific features of the pool, e.g., water features, heating systems. This method ensures that the selected pump can efficiently and effectively circulate the required volume of water within the specified time frame, thereby maintaining water clarity, proper chemical distribution, and overall water quality. This aligns with the CPO's responsibility to operate facilities safely and in compliance with public health standards, which implicitly require properly functioning equipment that supports these goals. An incorrect approach would be to prioritize the lowest upfront cost without considering the operational implications. This often leads to selecting a pump that is either undersized or significantly oversized for the system's needs. An undersized pump fails to meet the required turnover rate, directly violating the principle of adequate water circulation necessary for disinfection and filtration, which is a core tenet of CPO responsibilities and public health regulations. An oversized pump, while potentially circulating water quickly, can lead to excessive energy waste, increasing operational costs and environmental impact, and may also cause issues with chemical mixing and bather comfort, indirectly compromising the safe operation of the facility. Another incorrect approach is to rely solely on the pump manufacturer's generic recommendations without a site-specific analysis. While manufacturers provide guidance, their recommendations may not account for the unique hydraulic conditions of a particular installation, such as pipe friction losses or elevation changes, which are critical for accurate pump selection and can lead to inefficient operation or failure to meet performance requirements. The professional decision-making process should begin with a thorough assessment of the facility's hydraulic design and operational requirements. This includes understanding the volume of water to be circulated, the required turnover rate based on CPO standards and local health codes, and the total dynamic head the pump will need to overcome. Consulting with a qualified pool engineer or hydraulic specialist can be invaluable. Once these parameters are established, the operator can then evaluate pump specifications, considering energy efficiency, durability, and warranty, in addition to flow rate and head capacity. The goal is to select a pump that provides optimal performance and efficiency for the specific application, ensuring compliance with all regulatory requirements and promoting long-term operational success. Question 20. The efficiency study reveals that despite adequate pump operation and filtration, certain areas of the public pool consistently exhibit lower sanitizer levels and increased turbidity. Considering the design principles of public pools, which of the following actions is the most appropriate initial step to address this persistent issue? Option A. Adjust the pump's operational schedule to run at higher speeds for longer durations. Option B. Increase the overall chemical dosage to compensate for the perceived lack of sanitization in affected areas. Option C. Recommend replacing the existing filtration media, assuming it is no longer effectively removing debris. Option D. Review the pool's hydraulic design, focusing on the placement and type of water inlets and outlets to ensure proper flow patterns and complete water turnover. The correct answer is D. Review the pool's hydraulic design, focusing on the placement and type of water inlets and outlets to ensure proper flow patterns and complete water turnover. Explanation. The efficiency study reveals a recurring issue with water circulation in a newly designed public swimming pool, leading to inconsistent chemical distribution and potential dead zones. This scenario is professionally challenging because it directly impacts patron safety and operational effectiveness, requiring a deep understanding of hydraulic principles and their application in pool design. The challenge lies in identifying the root cause of the circulation problem within the design itself, rather than attributing it solely to operational errors. The correct approach, which involves re-evaluating the pool's hydraulic design to ensure adequate flow rates and proper placement of inlets and outlets, represents best professional practice. This aligns with CPO certification principles that emphasize the importance of proper pool design for maintaining water quality and safety. Specifically, it addresses the fundamental design principle of achieving uniform water turnover throughout the entire pool volume, as mandated by health codes and industry best practices that aim to prevent stagnation and ensure effective sanitization. An incorrect approach that focuses solely on increasing pump speed without addressing the underlying design flaws is professionally unacceptable. This fails to acknowledge that pump capacity is only one component of effective circulation. The hydraulic layout is paramount. Such an approach ignores the regulatory requirement for a properly designed circulation system that ensures all water is filtered and treated. Ethically, it represents a superficial fix that does not guarantee long-term water quality or patron safety. Another incorrect approach, which involves adding more chemicals to compensate for poor circulation, is also professionally unacceptable. This is a dangerous practice that can lead to overchlorination or improper chemical balance, posing health risks to swimmers and potentially damaging pool surfaces. It violates the principle of maintaining safe and balanced water chemistry, a core responsibility of a CPO, and disregards the regulatory framework that prioritizes effective water treatment through proper circulation. A third incorrect approach, which involves blaming the filtration system for the circulation issue without investigating the design, is professionally unsound. While filtration is critical, it is downstream of circulation. If water is not reaching the filter effectively due to poor hydraulic design, the filter's performance will be compromised regardless of its capacity. This approach fails to conduct a thorough root cause analysis, which is essential for effective problem solving and adherence to professional standards. The professional reasoning process for similar situations should involve a systematic approach. First, thoroughly understand the observed problem. Second, consult the pool's design documents and relevant regulatory guidelines. Third, analyze the hydraulic principles at play, considering inlet/outlet placement, flow rates, and turnover times. Fourth, identify potential design flaws contributing to the issue. And finally, propose solutions that address the root cause, prioritizing patron safety and regulatory compliance.